Assalamualaikum and salam sejahtera. In this class, we're going to look at correlation and regression. Basically, we're going to look at how do we measure the relationship between two quantitative variables and how we construct an equation that describes that relationship. To do that, we will look at two topics. First is correlation and second is simple linear regression. First, correlation. Correlation basically measures the relationship between two variables in a single sample. It means that when we observe or we obtain the responses from a sample, and in that sample we want to measure the relationship of any two variables, then we need to perform correlation analysis. Correlation analysis to get the correlation between the two variables can only be done for quantitative data, and correlation is measured by statistics called Pearson's correlation coefficient, and it is denoted by the symbol R. The Pearson correlation coefficient R contains two information. First is the magnitude of the relationship, how big or how strong the relationship is, as well as second, the direction of the relationship. The magnitude of the relationship is given by the number, in this case 0.85, and the direction of the relationship is given by the symbol for that number. If it is positive, we say that the relationship is directly related, and if it is a negative number, we say that the relationship is inversely related. When it is positive, which denote a direct relationship, it specifically says that if one variable increases, the other variable also increases, or if one decreases, the other variable also decreases in the same direction. If the direction is given by a negative value, the relationship is inversely related, which means that the direction or the movement or the changes in the values will be in opposite direction. If a value of one variable increases, the value of the other variable decreases. Let me repeat that again. In an inverse relationship, if a value of one variable increases, the value of the other variable will decrease. They are moving in opposite direction. Similarly, if one decreases, the other one increases, again in opposite direction. If the changes is in opposite direction, we say that they are inversely related. This scale shows how we interpret the value of R. As I've mentioned before, R can either be positive numbers or negative numbers. Positive numbers means positive correlation or direct relationship, as opposed to a negative correlation which denote an inverse relationship. The value of the Pearson correlation coefficient or the magnitude denotes the strength of the relationship. The higher the value, the stronger the relationship. The value of R has a maximum of -1 to +1. So the value of R range from -1 to +1, where -1 denotes a perfect negative or inverse correlation, and +1 denotes a perfect positive correlation or a perfect direct correlation. Here, the formula to compute R is given. It looks complicated, but the calculation is not difficult, which I will show you why. R is given by this formula: n times the summation of xy minus the sum of x multiplied with the sum of y divided by the square root of n times sum of x squared minus the square of sum x and multiply with n times the sum of y squared minus the square of sum of y, where x and y are two quantitative variables. This is something that you need to remember, that Pearson correlation coefficient can only be calculated on quantitative variables. In other words, Pearson correlation coefficient can only be used or be applied for variables having the scale of interval or ratio, not nominal or ordinal, because only interval and ratio scale are quantitative variables, whereas nominal and ordinal scale are qualitative variables. This exercise will show how do we calculate the Pearson correlation R. The question given to us is that from 6 respondents, the distance traveled to workplace in kilometer and the travelling cost in ringgit were measured and are given in the table below. Compute the correlation coefficient for these two. So we have two variables, two quantitative variables, distance travel and travelling cost. And the values of distance travel and travelling cost were obtained for a sample of 6 respondents. To help us solve the problem, I have constructed this table to assist us in calculating the value of R. The first column represents the respondent, and the second column represents the distance traveled, and the third column represents the travelling cost. The first 3 columns were given to us in the question, and if we sum the column of distance, we will get a total of 53. So this value of 53 actually is the sum of x. If we total up the third column, we will get the sum of y, which is equals to 24. The last 3 columns are pre-prepared for us. The fourth column is given by x squared. How do we get x squared? Is by squaring the value of x, which is 15 squared, and 15 squared is equals to 225. For the second respondent, the value of x is 6 and 6 squared is equals to 36. And if we continue, we will get all the values for x squared for every single respondent, and the total is given by the sum of x squared with a value of 541. The third column that we construct or we compute is the column for y squared. Basically, this column shows the value of the, the y value squared for each respondent. For the first respondent, y squared is given by 6 squared, which is 36. For the second respondent, the y value is 3 and 3 squared is equals to 9. For the third respondent, the value of y is 4 and 4 squared is equals to 16. And we continue to do for the rest of the respondents. And the total for this column is 106, which is your sum of y squared. Lastly, we have a column for x, y, which is the value of x multiplied with the value of y. For the first respondent, it is 15 multiplied with 6, and the value is 90. For the second respondent, the value of x is 6, the value of y is 3. So 6 multiplied with 3 is equals to 18. And if we continue with the remaining respondents, we will get a total of 238, and this value represents the value of sum xy. So just to repeat again, this value is actually your sum of x, because it is the sum of all the x values, and the sum of all y values is equals to 24, and this 24 is your sum of y. And then the fourth column is x squared, and this value is your sum x squared. And this column has a total of 106, which is the sum of y squared. And for the last column, for the column of xy, the total is 238, and the total is actually the sum of xy. Now we have all the values that we need to calculate the Pearson correlation R. And before we proceed with calculating R, I just would like to identify n, which is equals to 6, because we have 6 respondents. So R is n, the value of n is equals to 6, times the sum of xy. The sum of xy is here, and the value is 238, minus sum of x. Sum of x is 53, times the sum of y. The value for the sum of y is the value when we total all the values in the column of y, which is equals to 24, divided by the square root of n, which is 6, times the sum of s squared, which is the sum of the s squared column, which is 541, minus the sum of s, 53, squared, so 53 squared, times n, which is equals to 6, times the sum of y squared, which is the value given by the column of y squared. So the value of sum of y squared is equals to 146, minus the sum of y squared, which is the sum of y, 24, squared. This is 1428. 6 times 238 is equals to 1428, minus 53 times 24, which is 1272, divided by the square root of 6 times 541, which is equals to 3246, minus 53 squared, which is 2809, times 6 times 106, which is 636, minus 24 squared, which is equals to 576. One four two eight minus 1272 is equals to 156, and this is next is 3246 minus 2809, which is equals to 437, and 636 minus 576 is which is equals to 60, and this is equals to 156 divided by the square root of 26220, and if you solve this, you will get the value of r to be 0.96. From these results, we know that the strength of the relationship between s, distance travel, and y, which is the cost, the traveling cost, is very strong because it is almost 1.0. The value, the magnitude is 0.96, which is strong, and it is positive, so it is directly related. Means that when x increase, y will also increase, or when x decrease, y also decrease in the same direction. If we interpret these results, we can say that when distance increases, the cost will also increase. Or when distance decreases, cost will also decrease. So this is how we interpret the value of the correlation using Pearson correlation coefficient R. Next, we're going to look at simple linear regression. Simple linear regression is based on a cross-sectional data. It means that data that is obtained at a particular point of time, not over a period of time. It is an equation that relates a single dependent variable y and a single independent variable x. And this relationship is given by y as a function of x. It means that the value of y is dependent upon the value of x. That is the reason why x is called the independent variable, because the value of x does not depend on the value of y, but y is called the dependent variable because the value of y depends on the value of x. Similar to Pearson correlation coefficient, when you want to construct a simple linear regression, both the variables y and x must be quantitative. In other words, you cannot perform a simple linear regression analysis when either one of the variables are not quantitative. Y and x is linearly related. It means that the power or the exponent of x, the independent variable, must be equal to 1. When the power or the exponent of x is not equal to 1, then the relationship between y and x is non-linear. The regression equation between y and x is obtained using the ordinary least squares method, which I will show later. To illustrate how we perform a simple linear regression analysis and construct and determine the equation that relates y to x, we will use this simple data, and from this data we can construct a simple linear regression line. This data will give a regression line equals to y point 3 y equals to 3.25 plus 1.97x. The value of 3.25 is called the y-intercept because it is the point where the regression line intercept the y-axis, and the value is given from this equation, which is equals to 3.25. The value of 1.97 is the slope of the line, and this slope is denoted by the symbol b, and b is equals to 1.97. So in simple linear regression analysis, our aim is to construct this regression line so that we can get an equation similar to this. The formula that we use to obtain the regression equation when the equation is given by y equals to a plus bx, and from the previous slide we know that a is the y-intercept because this is the value that intersect the y-axis, and b is the slope which 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 is denoted by the value or the symbol b. To obtain a and b, we use the following two formulas. The formula for b is given by n times the sum of xy minus the sum of x times the sum of y divided by n times the sum of x squared minus the sum of x squared. Once we obtain the value of the slope b, we can now proceed to calculate the value for a, which is the y-intercept. A is given by the sum of y divided by n minus b, which is the slope that we calculated earlier, times the sum of x divided by n. We will use the same data that we saw earlier in the exercise of Pearson correlation coefficient to now determine the regression equation that represents the relationship between traveling cost and traveling distance. This is the same data that we saw earlier. Again, if you realize this is the same data and the sum of each column is given to you, and this is actually the sum of s for the column of s. This value for the column of y is the sum of y. For the column of x squared, the value of 541 is the sum of x squared. For the column of y squared, this value 106 is the value of the sum of y squared. And for the last column xy, the value 238 is the sum of xy. We now want to get a regression equation of y equals a plus bx. To determine the regression equation of y equals to a plus bx that relates between the variable of y and the variable of x, we need to determine the value for a and the value for b. We need to get the value for b first because we need the value of b in the equation to calculate the value of a. B is given by the sum of n times the sum of xy, which is n is equals to 6 times sum of xy, which is the value given by the column xy, which is equals to 238, minus the sum of x, which is 53, times the sum of y, which is given by the column y and has a value of 24, divided by n, which is again 6, times sum of s squared. The sum of s squared is given by the column s squared, and the value for the sum of s squared is equals to 541 minus the value of sum of s, which is 53 squared. This is equals to 1428 minus 1272 divided by 3246 minus 53 squared, which is equals to 2809 equals to, let's erase that, equals to 1428 minus 1272 equals to 156 divided by 3246 minus 2809, which is equals to 437, and B equals to 0.36. Once we have obtained the value for B, we can now proceed to calculate the value for A, which is given by the sum of y divided by n the value for the sum of y is equals to 24 divided by n is equals to 6 minus b. We have calculated b to be equals to 0.36 times sum of s, which is equals to 53 minus n, which is equals to 6. This is equals to 4 minus the product of 0.36 times 53 divided by 6 is equal to 3.18, and A is equals to 0.82. With the value of B equals to 0.36 and the value of A equals to 0.82, now we can finally construct our regression equation, which is y equals to A plus BS, and replacing the values into the equation will give us A equals to 0.82 plus 0.36x. If we were to construct or draw the graph that is represented by this regression equation, we will have something almost similar to this, where the vertical axis is the y value and the horizontal axis is the s value, and the regression equation is given by y equals to 0.82 plus 0.36x. The y-intercept is the A value and A value is 0.82, and the slope is B, and the value for B is 0.36. Okay, so there we have it. We have calculated, or we have determined the regression equation, and from the regression equation we know that the slope of the regression line is equals to 0.36, and the regression line intercept the y-axis at the value of 0.82. So this value is the value of A, and this is the value that intercept the y-axis. Alright, so that's all that we have for today, and what we have seen is how to determine, or how do we quantify the relationship between two quantitative variables, and the statistics that we use to measure the to measure the relationship between the two quantitative variables is the Pearson correlation coefficient, denoted by the symbol R. And R has two information, which is the direction of the relationship, which is given by the sign of the correlation coefficient, either it is positive or negative. And the second information that we get from the Pearson correlation coefficient R is the magnitude, and the magnitude is given by the number in the correlation coefficient, and the higher the number, the stronger the relationship is, and the lower the number, the weaker the relationship is between the two quantitative variables. And we have also seen how to construct a simple linear regression equation given by y as a function of x, where y is the dependent variable and x is the dependent variable. And from the equation we know that A represents the y-intercept, which is the value that the regression equation intersect the y-axis. And we also know that from the regression equation, the value of B represents the slope of the regression line. Okay, that's all for this lecture on correlation and regression. Thank you.